Example 2. Which vehicle gets better gas mileage? A car that travels 408 miles using 12 gallons of gas, or a truck that travels 448 miles using 14 gallons of gas? Real world problem. This is the sort of stuff that you want to figure out when you're in the market for a car or you figure out which vehicle to use. So, to find the better gas mileage, which is miles per gallon, write each rate as a unit rate by finding the miles per gallon. So, we have two rates here. 408 miles for 12 gallons and 448 miles per 14 gallons. Start with the one on the left. How many miles per gallon? How are we going to find that out? Well, we divide by the denominator, right? So divide both 408 and 12 by 12. We get 1 gallon. 408 divided by 12 is 34 miles per gallon. That's pretty good for a car. Yeah, 34 miles. It's about how much my car gets. 34 miles to the gallon. MPG, if you want the acronym. On the other side, divide by 14 because 14 is the denominator. We need 14 to be 1, so divide 14 by 14. 448 miles divided by 14 is 32. Don't worry, there's dollar signs. Ignore the dollar signs. Dollar signs don't matter. The truck gets 32 miles per gallon, which is awesome. I've never seen a truck get 32 miles per gallon. But in this case, with the vehicle that can travel farther on 1 gallon of gas is the car with a better mileage. In this case, that is the car, because it travels farther on 1 gallon of gas than the truck does. Look at example 3. Paul went to a grocery store to buy potatoes. A 10-pound bag of potatoes cost $4. A 6-pound bag of potatoes cost $2.70. Which is the better deal? Well, to find the better deal, we're going to write each rate as a unit rate by finding dollars per pound of potatoes. You've seen this setup before. This is the third time. Let's look at it again. $4 per pound. It's a rate because we have two separate units, dollars and pounds. Notice that the rates stay the same. When we're looking at the unit rate, it's still dollars on top and pounds on the bottom. To go from 10 pounds to 1 pound, what do? Divide by 10, we end up with 40 cents for 1 pound of potatoes for the 10-pound bag. On the other side, 6 pounds divided by 6 is 1 pound. We end up with 45 cents for 1 pound of potatoes. So, which one costs less per 1 pound of potatoes? That's the better deal. In this case, it's the 10-pound bag. 10 pounds for $4 is a better deal than 6 pounds for $2.70. Paul went to the grocery store to buy potatoes. That same 10-pound bag still costs $4, and that same 6-pound bag still costs $2.70. What is the lowest price he will pay for 20 pounds? So he didn't need 10 pounds of potatoes. He's having a party. He needs 20 pounds of potatoes. They're having some French fries and some mashed potatoes or something. Let's use equivalent rates. We already know that the better deal is the 10-pound bag, so we don't even need to use the 6-pound bag. We already know that the 10-pound bag is the better deal. I noticed that the original rate of 10 pounds can be multiplied easily to get 20 pounds, so no need to use the unit rate we found in the last problem. I can go straight to equivalent rates. If the original rate of 10 pounds couldn't be multiplied easily to get the new rate of 20 pounds, for example, if the 6-pound bag had been the better deal, then using the unit rate would have been most helpful. However, we're not using the 6-pound bag, we're using the 10-pound bag. And since 10 is easily multiplied to get 20, we'll just go straight from there. $4 for 10 pounds equals how much for 20 pounds? Well, how do we go from 10 pounds to 20 pounds? We multiply it by 2. Same as we do to the bottom, we do to the top. 4 times 2 is $8 per 20 pounds. There is an assignment on Google Classroom for lesson 2.5 and an exit quiz. Please, please, please let us know if something is not clicking. Even if you just want to clarify something, we're here for that. Come see us.